Hey everybody, and welcome back to Randy Bordeaux's Tech Talks. Today we're going to be going over kind of an overview for Azure networking. And one of the things that I've noticed, I get this question a lot. People see the magic of Azure and the cloud, and they don't really understand how things connect or where those things are controlled. So we're going to kind of dive in and take a look at some of this. So I'm going to share this out so you guys can kind of see what I'm looking at. So as you can see, we're looking at the Azure Portal, right? If we go in here, you can create resources and have virtual networks and all that, right? So part of this is you need to understand how this works as far as networking. So Microsoft has this global network, right? So you got 165,000 miles of fiber connection that links all these data centers and all these regions all over the world. So there's 61 regions or so right now, and they keep growing. When I first got into Azure, there was far less. Even just a couple years ago, there was only 50 some of these regions. Now we're hitting 61. But these are not just Azure. These are Bing, Dynamics, Xbox, all the different Microsoft products are running over this global network, okay? So as you can see from this picture here, right, these kind of greenish light colored dots here, these are the data centers. And then the orange ones is the edge. And then of course the line is the network. So Microsoft is always building these things out, right? And the thing people don't understand about this is there's this global network that supports all this infrastructure that we don't see. Azure has a high level infrastructure, everything they control, and then there's the infrastructure we build within that, right? And Microsoft is always pushing the boundaries on this. Right now, they're working on a data center that will be underwater. It's basically a big steel tube that they're going to sink in the ocean and run a data center there that's going to connect with the fiber. Great, cool, sounds wonderful. But those are the kind of things, they're always adding these. So the piece we need to understand, and if you look, and this is Microsoft documentation, right? So here's all our data centers and our regions and everything, right? This is set up to give us the best possible experience. And you can read through this and it has a bunch of detail on how to do this. And I'll put these links in the article. You can also come here and they publish the 30-day round trip latency figures. They use Thousand Eyes to measure all this stuff, which is a great tool, right? And then you can actually look and see from what region to what region, right? So if we blow this up, we can actually see, well, West US to West US 2 is 22 milliseconds round trip, right? And they publish these so you can kind of take a look at them. So if you're building something where latency is going to be a factor, right? You're doing something that's you need really low latency for, you may want to look at this and you may want to say, well, what do we have? Well, Japan East to Japan West is only 8 milliseconds, right? So depending on where you're at, you can look at your region and see what other regions you want. This comes into play if you're setting up redundant systems, right? So if you want to have actual redundancy in Azure, you're going to need traffic managers and you're going to need replicated machines and availability sets and availability zones, right? And the idea is if I'm operating in West US and West US goes down, right? That means your servers are down, your network's down, right? All your resources are down in there. So you can't just have, an availability set within the same region or an availability zone that's just doing it in the same region. If the whole region goes down, which is very unlikely, but not unheard of. So what we can do is we can say, okay, we want to have West US as our primary, but we want to have US Central. So Central US here, we want that to be our secondary, or we want to come over here and say, well, let's use West Central, right? And not every region connects to every region. So you got to do a little research and find out which regions are going to connect to which regions, because you want a direct connection. You don't want to be routing through other regions to get there, because that's just going to increase your latency. So for instance, South Central and West US 2 connect to each other, right? And if we follow this over, West US 2, we got 44 milliseconds, right? That's our latency between these. So I could have South Central US as my secondary and West US 2 as my primary, which basically means that I'm going to put primary servers in West US 2, secondary servers in South Central US. Okay. Then I can set up a traffic manager, and I can set up VNets that are going to mesh, and we're going to peer and do all that happiness. And then if something happens and West US 2 goes down, that traffic manager is going to identify that West US 2 is down and automatically route that traffic to South Central, or to, yeah, South Central US. So we come back, right? We're going to look at this, and there's internet routing preference, and this kind of goes over how this works. Now, the gist of this, kind of the high level overview, is if you are routing services to a destination, and if you're both on Microsoft services and you're routing to other Microsoft customers, it's going to stay in the global network. But say you're going to a website that's hosted on Amazon or something, right? It's going to stay on the global backbone as long as it can, until at the very end, it's going to find what they call a POP, a point of presence, closest to the destination. Then it will exit the global network. This minimizes your time that you're traversing the actual internet, because all that time you're sending traffic within the Microsoft global network. That's a closed network, essentially, right? It has these POP, these edge routers and stuff that lets it go out. But if you're routing to Microsoft services, things like that, you're not leaving that. You're never actually going out on the public internet. You're using internal IPs for routing, and that's the routing you're going with. Now you can change this, and you can have different routing preferences and tell it, no, I want to go out over the internet. And it will do the opposite. It will exit as soon as possible to get out to the public internet. Now, there may be some times you want to do that. I don't particularly recommend doing it. I like to stay within the global backbone network if I can. So our next piece, right, let's look at this. How does it actually get to the global backbone? Well, say you have a storage account, and you want to have that storage account that's accessible on your virtual network. Well, as the virtual networks go, we have virtual networks, and then we're going to have subnets within those networks. Those subnets, when we build them, all right, let's go build one. All right, so let's come in here. All right, so we're going to build a virtual network real quick. All right, so we'll just throw this in here, throw anything in, because this is what we want to get to, subnet. Now on this right here, you'll see the service endpoints. This is what allows that traffic, okay? Right now I have no service endpoints. So if I create a storage account and say I want to use it for profiles, so I'm doing Windows Virtual Desktop, I'm going to store my profiles in this storage account. If I don't come in here and allow the service endpoint from Microsoft.storage, then it's not going to have a choice but to go outside on the internet and come back in, right? And then I have to make that publicly accessible. But I don't need to do that. I don't need to expose that, right? I can shrink my attack surface, right, which gives me better security by allowing a service endpoint. And then when I create the storage account, I can deny public access, right? It doesn't need to have any access for the public out on the internet. It can use all internal route over the backbone network, and then I'll be able to communicate, right? Now, when I add this, of course, my virtual machines will have to be in this subnet, right? So that gives us one piece, right? So that's how we're going to get there. And that's what this article is about. So this gives you that service endpoint, gives you a direct connection. Okay. It utilizes private IP addresses to get there. And this kind of gives you what's generally available for this. And then there's a few things that are in public preview, and you'll see those change from time to time. Right? And there's even this update page where you can see it. So your key benefits for this is improved security, right? If you're on virtual private address spaces, you're not overlapping, you're not going out to the internet, you're shrinking that attack surface. And that's one of the primary things you want to do is shrink that attack surface. It also gives you the optimal routing, less management, right? There's a few limitations you'll come into. Honestly, I've never actually run into any of these, right? So there's certain things that can't be used for, right? Obviously, you cannot communicate using a service endpoint from your on-premise infrastructure, right? It doesn't make sense. The whole purpose of it is to communicate from Azure resources, from Microsoft resources to Microsoft resources, not from your on-premise resources, right? And then this goes in and talks about how to access them and how to do these things. If you want to access them from on-premise, right, you have to route it over an express route and then go into a virtual network where then you will be able to access it. Right? And then this goes on, gives you the configurations and some considerations for this. Right? This part is what I wanted to kind of focus on here. Network security groups. With service endpoints, you can use service tags in order to allow traffic. Right? And this is another part of the networking, right? It gets very complicated, but Microsoft likes doing things in layers, especially with security. So when you look at this stuff, right, you're going to have a virtual machine that's in a subnet on a virtual network in Azure, right? You're in your resource group and all this stuff, right? Well, say we're going to talk from one VNet to another VNet, okay? And let's see. Oh, I don't have Visio on my machine. So, and I don't remember the name of what that. There is a resource out there that lets you do it. Diagrams. Right? So here. Say this is going to be our VNet that we're talking about. Now let's make this our VM. Right? Our VM is going to be in a subnet. So we've got a VM that's inside a subnet, and then that subnet is now inside a VNet. Right? So this is kind of what we're looking at. And then we're going to do the same thing. Right? We want to have another one over here. Now, part of this, and let's turn on our cool ones here so we can get some of these. Now, we've got two VMs in separate subnets and separate VNets. We want to talk between the two. Now, this is going to be super simple, right? But if we look at this, and where is our, we're going to have a network security group that is on here. Then we're going to put one on this subnet. And then we're going to put another one that goes on the VM. And another one on the VM over here. All right, so now we have some security. But network security groups are based upon the idea that you have already passed through a firewall. Okay, and somewhere in this, there is a firewall for me to look at. This will work. This will be our firewall. All right. So each VNet is going to have a firewall. So how traffic is going to flow here is, say you're coming from this VM right here. You're trying to send just a ping, right? So ICMP traffic. It's going to check this network security group here at the VM level. It's actually attached to the network interface on the VM. And it's going to see if ICMP traffic is allowed to the destination that you're trying to get to. If it is, we're going to say it is. It's going to say, okay, you can exit and go to the subnet. Now the subnet has a network security group that is also going to inspect it and ask the same question. Is ICMP traffic allowed from that destination to that, from that source to that destination? If it is, then it's going to say, okay, great. You can exit and you can go to the VNet. Now the firewall is going to inspect it as it tries to go out. It's going to say, well, is that traffic from that source to that destination allowed? And is there a path there, right? Now, the way these are right now, there's no way it can communicate because there's no connection from one VNet to another. So we're going to look at putting in peering, right? So if we put in peering, hey, look at that. We got a little there. Now we have VNet peering between these two. So it's going to hit the firewall and then it's going to say, yes, I can go out. Great. Then it's going to go and hit another firewall. That firewall is going to do the same thing. It's going to say, well, are you allowed? If you're allowed, it's going to let you in. But then it's going to hit another NSG to get into the subnet. Asks the same thing, allows in, hits another NSG before it finally gets to the network interface, which is then attached to the virtual machine and allows you to do that. Now, this is all within your environment, right? This is the layers that we're talking about. You go from NSG to NSG to firewall to firewall to NSG to NSG, right? And you're using peering, so you're actually going over the Microsoft backbone network to get there. You're not even going out on the internet, okay? Now, once you introduce going out on the internet, this gets more complicated because then you typically are going to have the same setup, but hub and spoke is kind of what the go-to is for this. You're going to have a hub network where everything connects. Then you're going to have a DMZ network, right, where your traffic goes to, and that's where your firewalls are, right? So the term for this, right, firewalls are deemed to be north-south traffic. That's basically coming in and going out. And then when you're traversing your internal network, NSGs, or the network security groups, are east-west, right? You're going across the network, you're already inside, okay? But why would we want all this, right? And part of this is because you want to have security and you want to know what things are doing and you want them to go in the correct way. Right? So with this, we're going to say, let's pop this in here, right? This is going to be our route table up here. Now this, we're adding another level here, right? So as traffic comes out, it leaves either the subnet, so it's going to leave the subnet. It's going to reference a route table and say, where do I go? That route table is going to say, well, I got you. You're going over here. I'm going to direct you on where to go. This does not take the place of firewalls, right? So your traffic is actually coming out of the NSG, out of the subnet, through the NSG, into the VNet, out of the VNet, through the firewall. And this is just a direction keeper. It tells you where to go, right? Think of it like, kind of like a traffic cop. You know, you're going over there, you're going over here, right? Now, when we add in this whole hub and spoke situation here, right? So let's do that. Let's add this. We've got our hub network down here, right? And then it's not really going to have any of that. It's just going to have traffic, right? It's going to go from, well, that is not what we want. We want to go from here to here. There we go. So it's peered, right? And then if we do the same thing over here, very bad with arrows, apparently. Okay, we're gonna kill that. Anyway, you're gonna have network peering from your network, from your VNet into your hub, right? This hub is going to have the peering. So you wouldn't actually have this right here, right? It would look like this, okay? You would have peering that goes from each network into the hub. And then this hub would say, okay, I'm going to let traffic back and forth, right? Now you would have another one down here that would actually be your DMZ, right? And this would have virtual firewalls, virtual network appliances on it, right? But it's the same thing, right? So your virtual appliances are essentially VMs, okay? So we're going to pull one of these down here and we're going to say, okay, that's your virtual network appliance. And typically when you have these, they're going to come in pairs. You're going to have load balancers, right? You're going to have internal load balancers and application load balancers, that kind of stuff, right? But for this, you're going to say, okay, well, we're going from the hub. Now we're going to go out to our DMZ, all right? There we go. Now we're coming from the hub down to the DMZ. And then out here, we're going to have the internet. Now, once you get out here and you go through this final firewall, now you're on the internet. So we're going through all this, right? Say you're going to ping Google, right? You're going through this NSG, this NSG, this firewall, this firewall, this NSG, if you have to go into the subnet for anything, right? Then this firewall, this NSG to get to your network virtual appliance, which then is going to inspect everything and then allow you to go back out, which takes you back through this NSG and this NSG and this firewall, and then to the internet. So my drawings suck. I'm sorry for that. But this kind of explains like this layered approach that you're doing. Okay. So your network peering is telling your VNets they can talk to each other over the Microsoft backbone. Your service endpoints are allowing your subnets to talk to the different Microsoft services that have endpoints available. Your network security groups are controlling that access inside your network environment. Your firewalls are controlling the access going in and out of your networks, right? So NSGs can only apply to subnets, right? And you would only apply firewalls to VNets, right? And then once you come out here to your DMZ environment and you're going through all this, you would also have application gateways, and you would have DDoS protection on the resources here to make sure they're not getting attacked. So what you're doing is you're only exposing this piece right here to the internet. That's what the internet's going to see and have public IPs and everything. And then once you come in, you can switch over and start routing things through internal load balancers and internal IPs using the Microsoft backbone in order to get places. And then you're going to have a route table, and you can apply route tables to multiple subnets if you need to. Right? The piece you have to watch out for is if you apply a 0.0.0.0 default route, right? That may be different, and it's just kind of a catch-all, right? Any traffic, it would direct it, right? And you see that with virtual network appliances. So that's kind of the layout, right? How the networking flows, and then how the security on the networking goes on top of that to help secure your environment. And this isn't the only security and the only networking. There are tons of things here, right? Just like if we add in express route, say we want to go on premise and we have an express route to do that. Okay, we're going to connect to this hub network to our express route, and then we'll have our on-premise. This will be our on-premise office over here. All right, so if you're sitting here and you want to ping to this VM up here, then you're going to traverse this express route, go in through this firewall, and hit this hub. And the route table is going to say, well, you're coming from this IP scheme over here, so you're going to route over to here, right? So it'll take over for that, right? And typically there'll be a network virtual appliance or something in here that route is going to say, you're coming from here, I'm going to send you to this virtual appliance. That virtual appliance is going to look at it, inspect the packets, and say, where are you going? And here's your path, and here's how you get there, right? So you may, in some cases, be coming across the express route, hitting the hub, going to this virtual appliance, going back to the hub, then going over here. And each time you're entering and leaving, you're getting inspected on the way in, on the way out, at all these multiple places. So it makes it very hard if you're trying to get to somewhere you're not supposed to. Okay. Now, the other piece on this is by default, these VMs have outbound internet access. So if you're on this VM and you need to get out, if you do not have a route table with a user-defined custom route or a BGP route advertised, then it's just going to let you go out to the internet outbound. Now, when you're coming in, if you're coming back in, then you're going to hit all these things, right? Now, with that being said, once you initiate from the inside, it establishes a session, and then you can communicate back and forth. That's how these RDP and different things work, right? So there is that. If you're initiating from inside, it's a little bit easier on your networking guys. So I hope that explains it. It's a very kind of high level, down and dirty how you do this. So if you have any questions, let me know. You know, I'd love to hear them. I'd love to hear what we need to add to this, what we need to change, how it would make it easier to explain it, or questions you have. Hey, I didn't get that. I want to go over that. Just let us know. And like and share our video. Come visit our website, randybordeaux.com. I'll put the links to all these pages that I went to, including this diagrams.net site, which is a really handy tool. And come back and see us.